This is a response to FE Peer Review, the Flat Earth Peer Review channel. The date is 13th of August 2020. So's the date on the video he just posted called How High Do You Have to Get to See Curvature? He used Walter Bislin's curve calculator. It's fine. My only complaint would be he did it over the Pacific Ocean, Salt Lake City and San Francisco, not over England. Who's ever heard of San Francisco? Come on, put it somewhere everybody knows about. Anyway, on screen is a program which will put a few white lines at the bottom of the screen for the Kármán line and the orbit of the ISS, and on the left for 10, 20, 30 and 40 pixels, assuming a 60 by 45 degree field of view and a 4288 by 3216 pixel resolution, which is much higher resolution than the display you're about to see, because I'm in mode 2, which doesn't have anything like that resolution. In fact, it doesn't have enough resolution to justify going step 2. I'm going to go step 4 there. What this program does, for each of a series of Earth radiuses, calculated using in the X% loop at line 30, starting with, well, not quite actual radius, but, you know, volumetric mean radius, and going up 5% at a time above that, a different colour for each one, plot the angle in radians times 20,000 down there at line 180. The difference between the horizon dip angle at the centre of your field of view and the horizon dip angle at the edge of your field of view, because you're dipping about an axis that's perpendicular to the direction you're looking. In red here we see no refraction at all, no atmosphere, no refraction, which is pretty accurate for the ISS, which it's about to reach, about there, but obviously generally not the case when you're near sea level. In green, this is just plus 5%, which would be a very unpleasantly hot day. And on this scale, the length of those 4 little white lines from the left side, the pixel count markings, those are actually 20 kilometers of altitude long each. So when you're talking about airliners, don't expect to see more than 40 pixels difference with that field of view. And here's cyan, which is approximately 0 degrees C, making the Earth look a whole lot larger, and therefore your little visible part of it look flatter than it really is, which is why some firsts will tell you to make observations on crisp, clear February mornings, because that's when it's really cold and the Earth appears flatter than it really is. And a special here for Mr. Sensible, a line at 30 kilometers altitude. There.